Hey guys, welcome to this session. Our topic is soil properties, and specifically we're discussing about the soil physical properties. Today, let's start with the soil pore size. We already seen other physical soil properties. So today we'll see these two soil pore size, and the other one we're going to see after this one. Now, this is soil pore size. It controls the water and air movement and storage. The pores come in all sizes, although clays have predominantly small pores and the sands have large pores. Now, most soils are a mixture of sand, silt, and clay particles. So there's a mixture of different soil pores. Now, an ideal soil condition is one with an equal number of large and small pores. The large pores allow for soil aeration, whereby this aeration is needed for the exchange of oxygen from the atmosphere and the carbon dioxide given off by these plant roots and the microorganisms. Now let's see the second one, which is soil permeability. Soil permeability, this is the ability of the soil to transmit water and air. As the soil layers or horizons vary in their characteristics, the permeability also differs from one layer to another. The pore size, texture, structure, and the presence of impervious layers such as clay pan determines the permeability of the soil. Now, water head in a soil is described by the term water content. Now, saturation, this is the soil water content when all pores are filled with water. Fluid capacity, this is the soil water content after the soil has been saturated and allowed to drain freely for about 24 to 48 hours. Now, the free drainage occurs because of the force of gravity pulling on the water. Now, when the water stops draining, we know that the remaining water is held in the soil with the force greater than that of the gravity. The other term is permanent wilting point, which is the soil water content when plants have extracted all the water they can. At the permanent wilting point, a plant will wilt and will not recover since it has already extracted all the water it can extract. Unavailable water, this is the soil water content that is strongly attached to the soil particles and aggregates and it cannot be extracted by plants. This water is held as films coating soil particles. Now, all these terms which we have seen above, all these terms illustrate soil from its wettest condition to its driest condition. Now, several terms are also used to describe the water held between these different water contents. Starting with the first one, that is gravitational water, which refers to the amount of water that is held by the soil between the saturation and the fluid capacity. Water holding capacity, that refers to the amount of water held between the fluid capacity and the wetting point. The plant available water, which is that portion of water holding capacity that can be absorbed by a plant. As a general rule, that plant available water is considered to be 50% of the water holding capacity. The other one is the volumetric water content, which is the total amount of water held in a given soil volume at a given time. It includes all water that may be present, including gravitational, available, and unavailable water. So I hope it's clear. Thank you for listening. We've discussed the two soil physical properties, the soil pore size and the soil permeability. We are left with one of the physical properties which we are going to discuss in our next session. Thank you.